So this is day 1 of 6.1, and we're just going to be talking about basic work with law of sines. We're also going to be doing a area formula for area of a triangle. But tomorrow is going to be a really important day. It's something that was maybe briefly mentioned in Algebra 2, but you probably didn't spend too much time with for the law of sines. It's called the ambiguous case. And ambiguous means unclear. So tomorrow, we're going to be solving triangles that are unclear what's actually going to happen. Will there be no triangle that exists? Will there be one triangle that exists? Or will there be two triangles that exist? So know that tomorrow is going to kind of like amp up because you'll have to look at all those cases. For today, it's just going to be real basic law of sines, which you probably did in Algebra 2. So first thing I'm going to say about the law of sines, and this is true about the law of cosines as well, which we'll get on Wednesday. It's a formula that we use to solve triangles, and I abbreviate that with the shape, that are not right triangles. So back in chapter 4 and also in geometry, you did some right triangle trigonometry. Well, we can use Pythagorean theorem to find a missing side. We can use SOHCAHTOA to find missing sides. We can use inverse trig, like inverse sine, inverse cosine, inverse tangent to find missing angles. But those things only work if the triangle is a right triangle. So we had to come up with some new ways to be able to solve for missing things, and that's what solve means. Okay, so I'm going to say find missing angles or sides. We had to come up with a way to be able to find these missing angles or missing sides for triangles that weren't right triangles. Well, you can see from the activity you just completed, essentially that's coming from right triangle trigonometry, right? You drew on those triangles an altitude and you created two right triangles. So we are using right triangle trig to get the formulas, law of sines, law of cosines, but now we're just going to be using those formulas. So you can draw any triangle shape that you want in your notes. Just want to make real clear that everybody, when you're working on a problem, you have to label the sides related to the angles. So like side A has to be opposite angle A in the triangle. Side B has to be opposite angle B, and side C has to be opposite angle C. And if you label it correctly, then the law of sines is true. The sine of A over A, so lowercase is side, uppercase is angle, equals the sine of B over B equals the sine of C over C. So this says, for any triangle, doesn't have to be a right triangle, the ratio of the sine of an angle to its opposite side is the same for all pairs. Okay, that ratio is consistent throughout all three pairs in the triangle. Sines of the angle and their opposite side. Another quick thing to note that you should just recall from geometry, and we'll talk more about this in the next coming days. Once you're finished solving, like your longest side, in this case it looks like side B is the longest, it should be opposite of your largest angle. And your shortest side, it looks like side C is shortest, should be opposite of the smallest angle. And then you should have a medium to medium pair. If you ever notice, if you draw it out and you label it and you notice across from my largest angle is not my largest side, then you have a problem in your solving. So that's a signal for you to go back and look at that. Why did that happen? What did I do wrong? Here's an example. You can draw any old triangle, label the appropriate pieces. Now today, I always think today is kind of a boring day in terms of homework because I've only given you the law of sines, so you know you're going to use the law of sines, and they're all going to kind of work the same way because we don't have an ambiguous case yet. be a total bummer. You're going to want something more challenging. Don't worry. Tomorrow we'll get a little piece of that. It's not really hard, though. But it's just in terms of like all of chapter 6, and when we put this all together for our quiz on Friday, like how do I get a problem like this and decide if it's law of sines, law of cosines, or ambiguous case? Well, I'll talk more about ambiguous case tomorrow, but in terms of law of sines and law of cosines, here's the thing that really kind of gives it away. If you can, in your triangle, find a pair of an angle and its opposite side, then you can use law of sines. So in this triangle, the way I've labeled it, I know angle C and I know side C. So I know the exact value of the ratio sine C over C. It is sine of 36 over 10. And the other two angles and side lengths and their corresponding sine lengths have to have that same ratio. So I can now use that to help me find my missing pieces. Okay, so if you can ever find an angle and its opposite side, that's a good time to use law of sines. We'll talk about ambiguous case tomorrow. What do you guys want to solve for first? I'm open to anything. A, side A, or angle A, Emma? You want to find angle A first? Okay. How will we find angle A? Emily says 180 minus 118 minus 36. Right? All three angles in a triangle always add up to 180? Unless we're in a non-Euclidean surface, that gets fun.
What?
Yeah. There's triangles that have more than 180 degrees.
Don't tell me that.
If you took, what, non-Euclidean geometry, college?
I feel like math has rules and there are also rules, so they're basically just
That's a beautiful hammer. Okay, so A is equal to 26.
we're gonna make these rules
Okay.
just to believe.
Now what do you want to find?
It only works
Side A.
once.
Okay, so if we know the ratio of sine C to side C, then we can say that that must be equal to the ratio for the sine of A, which is 26 degrees, divided by side A. How will you solve that equation? Tyler? Wait, say sine 36 divided by 10.
And then sine 26 divided by 10.
Oh, okay. Yes, can you give me a more algebraic approach to that?
Basically getting the a on the other side and then
Yes. Can anybody tell me how I might get A on the other side, or a method to solve? I will cross multiply this one, yeah. But if you know, like, that it always works out a certain way, so like that, you know, like what you're saying, true, right? But I like to actually solve it so that I could always answer it, right? So I'm going to cross multiply A times sine of 36. Oh, and I think actually I'm wondering if yours was the right order there. But then I'll have equals 10 times the sine of 26. And then how do you get A all by itself? Divide by the sine of 36. So I don't know if that's the same thing that you were saying, right? Okay. Everybody should get their calculators out and make sure it's in degree mode.
And it's just been dead.
Charge it.
I can't find the charger.
Bring it in. Set it in this charger.
I'm just been using this calculator.
Okay, now when you type this into your calculator, let's make sure everybody's calculator works. You gotta be in degree mode. Now, your calculator will bring up a set of parentheses for the sine of 26, so it is very important that you close that parentheses before you divide by the sine of 36. Can you give me that answer to the nearest 10? 7.5?
That's what I got. Oh, yeah.
I'm hearing a few people say 7.5. Do you guys agree with that?
Yes.
Let me know if your calculator is not giving you that same answer. Okay, so once we find side A, now we can find side B. Same way. You cannot go back to Pythagorean theorem. Why can we not use the Pythagorean theorem?
Because it's a
It's
not
not
a
a right triangle. Okay, if it's not a right triangle, don't use Pythagorean theorem to find your third side. Okay. So I'm going to go back to this ratio that I started with, the sine of 36 over 10. I always go back to the one that I was given because then it's exact. And now I can say the sine of 118 over b. Now, as you solve these, you'll start to get used to like, okay, they kind of solve the same way. So this one goes here, that one goes there. But if you're ever in a crunch on a test or a quiz, just solve it algebraically, right? Cross multiply b sine 36 equals 10 times the sine of 118 and divide by sine 36. So give me that to the nearest 10.
15.0.
15.0, okay. Equals 15. Now, what's a good way for you at the end of a problem, if you had some extra time on a quiz or a test, just to even check, not necessarily the accuracy of your answer, but the reasonableness of your answer? Are your answers even reasonable? What could you think about? Noah? This is a really great exercise for you to practice because it can save you some lost points here and there. It might be helpful in ambiguous case scenarios. Is the biggest side, 15, opposite the biggest angle? Yes. And is the smallest side, 7.5, opposite the smallest angle? Yes, which leaves the medium to be opposite the medium. So everything is corresponding. If at any point you solve a triangle and your largest side is not opposite your largest angle, there's something wrong. Okay, it should be true. Anybody got any questions for me? Okay, one more thing we're going to talk about real quick is area of a triangle. Tell me what formula you know for area of a triangle. Okay, base times height divided by 2, or you might say 1/2 times base times height. Both of those are the same thing. If I know information about my triangle, like the angles ABC or the sides on the outside ABC, do I have enough information to use the formula you gave me? The answer is no, because I don't know the height. So let's go back to that activity you were doing at the beginning of class. Let's draw in our height, which would be our altitude. We're creating a right triangle on the left and the right of this triangle, right? And so we can do just like we did in that activity. If we want to focus on the right triangle on the left, we can write an equation for the height using the sine of A. So we can say the sine of angle A is equal to h over c. You okay with that? From angle A, that's opposite over hypotenuse. And then that means that the height is really c times the sine of A. So where I see height in the equation you gave me, 1/2 times base times height, I can kick out that h and substitute in c times sine A. So one formula for the area of a triangle using just the angles or the sides around the triangle would be 1/2 times the base, because that's what I drew to, right? So B is my base, times the height, which we're saying is c times sine A. it's the same formula where we've solved for height using right triangle trig. Now, I used the right triangle on the left, but we could have used the right triangle on the right. We could have said the sine of angle C was equal to h over a, and then we would have said h is equal to a times sine C. So if I were to sub in a times sine C for that h, I will get another equation or another formula. It would be 1/2. I'm going to write it in alphabetical order, so I have lowercase a and lowercase b, and then times the sine of c. You could say b times a times sine c. And that's really the same formula. Okay. Can you tell me what the third formula would look like? One half times a times,
Sine B.
we have b times c, we have a times b. So we're going to have a times
C.
c, and then it's going to be times the sine of b. And we've got all of the three different formulas. We'd have to draw an altitude from angle A or from angle C to get that one. Okay, I'm not going to take the time to do that. These are all three the same formula. Okay. They're to use when you don't have this dotted H line in the middle, when you don't know the height of your triangle. And then visually look at what information is given for each of these. If you know side B, side C, and angle A, you know two sides and their included angle, the angle in between them. That's called an included angle. If we looked at this second formula, if I knew side A and side B and side C, or sorry, angle C, I'd know two sides and their included angle. A and B make up the angle C. And on this one, if I knew A and C, the formula uses angle B, the included angle. So in geometry, you use these shortcut abbreviations for congruence postulates. But what we have right here is side, angle, side. And in all three cases, the information that's given to me is side, angle, side. Use when given side, angle, side. If you know two sides and their included angle, you can do 1/2 times the two sides times the sine of the angle. Okay. So that's why I have these two drawings over here on this side board. If I had a picture like this where I knew the height, I would use my original formula, base times height divided by 2. If I didn't know the height, I could solve for the height, or I recognize I could just do 1/2 times the two sides times the sine of 20. So we'll put one example in our notebook, and then you'll have some time to work on your homework. We're going to find the area of this triangle if A is equal to 65, B is equal to 15, and C is equal to 22. Again, this is one of those reasons why this homework is kind of a dull homework. It asks you to find area, so you're going to use the formula I gave you. You don't have to think too hard about it. For purposes of notes, I'll go ahead and draw a picture with this. In 6-2, you'll get a second formula for area. And so I'll just quick sketch what this actually looks like. And this looks like a triangle where I know two sides and the included angle. Which basically is side angle side of given information. And so I use my formula we just talked about. The formula is just 1/2 times the two sides, so times 22 times 15 times the sine of the angle. So sine 65. And I just type it in, get an answer. We'll go to the nearest tenth again.
149.5.
149.5. Area equals 149.5. Generally, you'll be given, like in an application problem, miles or inches or something like that. So I'm going to go ahead and label it unit squared. Give it a label. Okay? So tonight's homework, you're going to be practicing basic law of sines. You're going to be practicing this formula for area of a triangle. You should know both of them by Friday when you take the quiz, and you will have to know both of them when you return from break in order to be able to do well on your Chapter 6 test. So, what are you going to do right now to make sure that you actually learn that information so that you can use it later? Here's your homework assignment. First 4 are solving triangles. I think 39 to 41 are area problems, and 47 is probably a word problem. And I got the first 3 on the board if you want to get started. But we have 8 minutes, so everybody should be working.